You know how your phone just knows it's you and unlocks instantly? Or how a self-driving car can somehow navigate a crazy busy street? Well, the magic behind all of that is something called computer vision. It's this incredible science of teaching machines how to actually see and make sense of our world. So let's pull back the curtain and see how it really works.
So let's start with a simple question. When we look at a picture, we see things, right? We see objects, we feel a mood, we understand the context. But what does a computer see? The answer is almost definitely not what you think, and it is the key to this whole entire field. And this is where things get really interesting. We see a vase of flowers. A computer, it sees a giant grid of numbers. Pixels, that's it. Each number just represents a value for brightness and color. There's no built-in idea of flower or vase or pretty. It's just raw, meaningless data, and that gap right there is the fundamental challenge we have to solve.
So how in the world do you get from a grid of numbers to understanding a vase of flowers? Well, you have to solve what scientists call the inverse problem. And honestly, this is the single biggest reason why teaching a machine to see is so incredibly difficult.
Okay, so think about it like this. An image is just a flat 2D projection. It's the effect of a rich, complex 3D world. The computer only gets that final picture, that 2D effect. And from that alone, it has to work backward to guess everything that created it. The shape of the objects, the way the light was hitting them, the different textures. It's kind of like being given only the answer, 42, and being told, okay, now figure out what the original question was.
I mean, in the real world, the process is pretty straightforward, right? You've got a 3D scene. That's the cause. Then light bounces off everything according to the laws of physics. That light enters a camera lens and creates a 2D image, the effect. Simple enough. We can call that the forward process.
But computer vision has to do the complete opposite. It starts with just that 2D image, the effect, and has to somehow reverse engineer the 3D cause. It is a massive, massive puzzle with tons of missing pieces and a whole lot of uncertainty. So if the problem is that hard, how do we even begin to solve it? Well, brilliant engineers and scientists have come up with a really powerful toolbox of methods to help computers start making educated guesses and piece that puzzle together.
So to crack this, they have this amazing toolkit. First, they use physics models to understand and predict how light and shadows should behave in the real world. Then, they use probabilities and statistics to handle all that uncertainty and make smart, educated guesses. And the real game changer? Machine learning. They train algorithms on millions and millions of images so the machine can learn for itself what the patterns of a cat or a car actually look like.
Okay, that's enough of the theory. Let's talk about where this tech actually shows up in the real world. Because trust me, it's not just stuck in some research lab. It is fundamentally changing how everything works, from huge industries all the way down to the apps on your phone. In the professional world, the applications are just massive. You have vision systems guiding self-driving cars and automating entire warehouses. They can perform these almost superhuman tasks, like spotting a microscopic defect on a factory assembly line or helping a doctor analyze a complex brain scan. This tech is the silent, watchful eye behind security systems, traffic cameras, you name it.
But this isn't just some far-off sci-fi technology for big corporations. It's something you probably use every single day, and you might not even realize it. It is literally right there in the palm of your hand. Seriously, just think about your phone's camera for a second. That little bit of magic that instantly finds all the faces in a photo, the software that flawlessly stitches together a huge panorama, or how it smooths out your shaky video. That is all computer vision. It's even the secret sauce behind Hollywood special effects, letting amazing CGI characters blend right into a real-world scene.
So, that was a pretty quick journey, right? We went from a simple grid of numbers all the way to a world where machines can actually interpret what they're looking at. Let's just tie it all together. So what's the big takeaway here? Computer vision is all about giving machines the power of sight by tackling that huge inverse problem. It's not magic. It's this amazing mix of physics, math, and of course, machine learning. And as we've seen, its impact is already everywhere, from automating factories to powering the features we love on our phones. And that really brings us to a final, pretty deep thought. As we get better and better at giving machines this incredible gift of sight, we have to start asking, what new things will they show us? I mean, if a computer can learn to see the world without all of our human biases and baggage, what will it end up showing us about ourselves?
Please like, share, and subscribe to the Simple ML Stories channel, and don't forget to hit the bell icon.